Hi guys, see you speaking again. Remember in the first video I presented you the PCB relays. In the second one I was showing you the project at work. It's exactly this one if you remember. In the third one I was showing how to test your PCB relays. And now in the fourth one we talk about the diagram and how to find the parts to make yourself the project. First of all, what generated the project? Again, it was the need to connect the printer to two distinctive computers. So I used the diagram taken from a very reputed magazine. And actually, I would like to tell you a couple of words about this magazine. It's the Elektor magazine from Netherlands, originally from Netherlands. Now it's all around the world. So there are two ways to get the magazine for yourselves. One way is to get the green membership so you can get it online in your mailbox. Second is the gold membership, when you can get both the printed and the electronic version. This is a simple project. However, for more complex ones, they have their own factory where they can build the printed boards for these projects. So I have here a sample of such a project. Between the close of the probe, I have now a coil 10 millihenries. So these are very special probes for a LCR meter, Kelvin probes. And the project itself is microcontroller based. Obviously on the display you get a lot of information, not only the size of the coil if you need to select, let's say I have 10 of them and I want to select the closest one to 10.00 millihenries, but it also gives you the resistance in ohms for the copper wire you have the coil, and a lot of other information related to the component. This is a complex project, so actually I received it in a form of a kit. Even the box was made by them, and they used the CNC machine to make the cuttings and everything, you know. So it's just a sample of what you can get as a project, okay? Another thing is, during the years, because I didn't want to miss diagrams, I ordered a whole collection of diagrams for all the years available. Back in time they were delivered on DVDs, but right now they can give it to you right away by mail on a little USB stick, so there's not a problem. Take a look, I have a lot of diagrams available on these DVDs. And I'm actually very grateful to the magazine and to their big team, simply because not only they gave me the permission to distribute to you the electronic diagram of that project, but if I'm going right here in the mailbox, they've made the article available for free for you guys to download. If you go simply in www.electormagazine.com/Chris, this is me. So they've made the link on my name. Take a look. I click on it. You go in the magazine, and right there into the diagram, there's the little diagram we're going to talk about in 2 minutes. And then if you click here on the download link, you get it right away so you can put it on your computer, okay? So very easy, and don't worry about this, it's going to be in the description of the video. So far so good. So now, talking about this diagram, it was made by Liam Muskie many years ago, and the principle is a very simple one. Here is a USB connector for the printer. Remember, the USB, it's by nature a serial connector, universal serial bus. Unlike the standard serial connectors existing before and the other protocols, where you have one line for reception, the other one for the transmission, this time, for the USB, they play with the differential. So there are two lines, but instead of being one for reception, one for transmission, they are differential lines. So imagine like you have a operational amplifier. So the two inputs are compared against each other. Why they do so? Simply because they want to minimize the electronic noise. This is why the lines are actually called D plus and D minus. Also, as a reminder, the USB standard, the USB 2.0 by the way, because the USB 5 it has, the USB 3 has 5 wires, but the USB 2 it has 4 wires. One of them is 5 volt, the other one is the ground, and the two remaining wires are these two ones I'm talking about, D plus and D minus. So the principle of operation is very simple. If you don't do anything, through its normally closed contacts, the first computer, which is this one where I have my mouse over it, it sends the information to the printer. That's it. But in the moment you play with the switch, with the little toggle switch here, you actually energize that relay, the coil, and by doing it, remember, in the bottom here I have the common, and this is the pole, remember from the last videos, and the pole is going to move over the other side, disconnecting the first computer and connecting the second one. So the second computer is going to send its two lines, D plus, D minus, to the printer. That's it. It looks like a very simple project to do, and the only thing you need as a main part is the relay, together with the appropriate connectors and the cables to have the two computers connected to the printer. Now, this is the version of the project you should do right away if you want to connect your two computers to the printer. However, what may happen, you may have the same problem I had, depending on how the voltage, the 5 volts, is transferred between the computers and the printer. You may have a problem sending the signals to the printer. So if it is the case, then you may be in the situation to modify a bit this diagram, and this is what I was going to do, showing you my modified diagram after the article published by Liam Muskie in the Elektor magazine. And what did I modify? I added one more group of contacts. Remember the group of contacts common, normally closed and normally open. I add in one more group here, and that's exactly what you can find here in the project you were seeing last time. This is why the relay, actually it contains 4 groups, because they don't make such a PCB relay with 3 groups of contacts. They either make one with 1 group, with 2 groups, or 4 groups. So this is one with 4 groups, and I'm only using 3 groups out of 4, so the 4th one is not in use, okay? But again, you should start checking the first diagram, the simpler one, and in case it's not working, you're gonna check the second one. Additionally, because I had access and it's very cheap to buy today, I was buying a toggle switch having double pole double throw instead of the single pole single throw used before, and by having a double pole double throw, I was also able to connect LEDs on both sides, because the original diagram, if I'm showing it to you again, this one, it only has one simple switch with 1 pole and the normally open contact. So in the moment you connect the switch, only then you're going to see the light going on if you connect a light here in parallel with the relay. In the updated diagram here, I have a LED connected here across the relay, of course through a limiting resistor, and I have another LED over here when the 5 volts are connected from the other computer, so you can see what computer is connected at a time, okay? So if I'm showing this to you right away on such version of the project, you're going to see, take a look, this is the USB cable coming from the first computer. So here is the connector for the PC1, and as soon as I connect it here, if you do nothing to the switch, you can see right away the green LED going on. So now the signal is going to be sent from this first computer to the printer connector. If you switch on the other position, nothing is going to happen right now because you don't connect the second computer to the printer yet. Here is the cable coming from the second computer. So here are my two Lenovo ThinkPad computers I want to connect. So I connect the second one, and in the moment you toggle the switch, then the first light, of course, it's going off, and the second one goes on, saying this is the second computer now connected. So first computer, second computer. So first Lenovo, the second Lenovo connected for the printer. Okay? So that's the principle of operation for the modified diagram. It's a very slight modification, actually. It doesn't change the principle of operation. Okay? Very good. So now let's go. To finish with the Elektor magazine, again, I want to show all my gratitude to the big team of the magazine for the permission they gave me to use this article for yourselves, and you're going to find all that information where? In the description of the video. So we've discussed a bit about the diagram, how is this working. I'm gonna, of course, put there the version, the modified version, this one, so you have access to it. And now, just a couple of things about the bill of materials. What do you need? So, on the first position here, I put some USB, the type B connector, because remember, this is the type of the cable everybody uses. USB-A on one side for the computer and USB-B on the other side for the printer. Is going to be a link most of you are used to buy from Amazon, but you don't have to. I'm going to make a mention a bit later. But you can find these connectors very easily. You only need two of them. And the link is below. And then for the printer, you're going to need to put on the project. You're going to need to put on the project the female of the USB-A, not the USB-B. USB-A, because the USB-B is going to be on the printer, okay? So you need this one as well. On the original project, I was following the indication of Liam Muskie, the author of the article. So I just bought connectors and plugged them directly on the board and soldered. However, because I couldn't find one in time for the USB-A, I had to buy a breakout board. And this is what I actually recommend for you to buy, the breakout boards, okay, for all the three of them. So this is going to be now the relay. The relay, you won't find it on Amazon. I put here the link. It's amazingly cheap for this kind of relay because I did not expect it to be found very easily. But I found it is a 5-volt coil relay, of course a PCB one, and here you find the link. If you go on the link, you're going to find it for only $4.50 per unit. Okay. Next thing you need, and here I'm going to ask for your attention, is going to be the printed board. So I have here a lot of them for small projects I'm using all the time. And what is interesting about these boards is that in order to use all the holes, because the size of the board is a typical one, the one I chose for this one is 60 millimeter by 80, so 60 by 80, remember that? So 60 is the smaller side and 80 is the longer side. But what is more interesting about it is that all the columns are numbered from 01, 02, 03, and so on. You can see it better here on the screen of the computer. 01, 02, 03, 04, up to 26. And the lines are numbered, the lines A, B, C, D, and the letters are right here. A, B, C, D, and so on, because in the moment I'm going to describe how to plug the parts on the board. then you're going to consider exactly like on a chess plate. You're going to check exactly the dots in order to place the components properly. So remember this. The columns are numbered 0, 1, 2, 3 up to 26, and the lines are also numbered A, B, C, D, and so on. Okay, from the first to the last one. So far, so good. For those of you who want to make it on a smaller footprint, like the original one I made, this is a board I bought from Adafruit, but actually I didn't buy it from Adafruit. Just to mention this for you, for the Canadian and American customers, is going to be very easy. I just want to show it to you right now. If I go right here, you're going to find an excellent distributor for electronic parts called Abra Electronics. They have a Canadian branch. They have another one in the United States in New York State. So you can very easily order from their site. All the parts are described very accurately, and it's going to be very easy to buy this board from Adafruit from their site. Okay, so there's not a problem. It's going to be very, very easy for you to order. Okay, very good. So that being said, we go further. The switch. I couldn't find only one switch to order. You can order maybe a couple of them together, the switches. And these are for the first version of the project, where only a single pole double throw is required. Okay. And for those of you who want to make the other one, so you don't have to buy both of them, either this one, either this version, or that one. This is double pole double throw. That's exactly the one I have. Exactly the one I have. Okay. So very easy to find, and I'm gonna put that document for you in the description. Okay. And then the last thing you need is to buy 3 identical cables, and that's another beauty of the project. You just need 3 identical cables you can buy for a very low price. USB-A on one side, USB-B on the other side. The length is not an issue, in my opinion. Just remember that the standard USB 2 allows you easily to put a cable about 16 feet long, or in the metric system is about 5 meters long. Okay. Otherwise, you may need the cables provided with amplifiers on the way, but usually in a room, 2 5-meter cables should just be enough. So you just need 3 such cables. Additionally, other parts you may already find in your junk box: 2 LEDs, 3 or 5 millimeter diameter, 1 green, 1 red, or any other 2 distinctive colors, 2 resistors between 220 and 330 ohms. Even if you don't have such a resistor, you have one of 500 ohms, it's still gonna work fine, don't worry. And 1 signal diode, 1 N4148, or any rectifier from the 4000 series, as I mentioned last time, from 4000 series. The numbers are from 4001 to 4007. Okay. Another mention for you is a note about the shipping prices. There is an excellent article here from CBC by Philip Drost, and I put you the link right here. That's the document referring to what? To the bills, the bill of materials. Okay, so far so good. So now, what's remaining is how to place these parts on the printed board. So for that, I have here 3 documents, and we're going to take them in order one by one. I'm going to put this one first here. Let me see, step number 1. This is the one. So remember, what I've said. On the printed board, all the columns are numbered 0, 1, 2, 3, 4, 5, and so on up to 22. And the lines are also numbered. Actually, they have letters A, B, C, D, and so on. So when I say here D5, it's exactly because it's on the line D and the column 5. Okay? So D5 and J5. What is this about? Here I have the USB-B connectors. When you get them, they come together. I bought a whole bunch of them. You just separate them very easily. And I measured exactly the distance between these two holes. When you place the connector to look very nicely right here, and the connector to be aligned exactly like this one here, the position for these two holes are exactly if you put the connector with the holes on D5, J5. One mention though is the holes on the printed board you are going to order. These holes are 0.8 millimeter diameter. And the hole here on the little breakout board is, if I'm showing this to you right now, if I'm zeroing my caliper and I measure right now the diameter of the hole, is approximately 3 millimeter diameter, or if you want in American gauge 3.2, which is about 1/8 of an inch. Okay, so you're going to need about, take a look, it's almost 3 millimeter diameter. Okay, again in the American gauge is approximately 1/8 of an inch. So you're going to need exactly on the position I'm specifying there, D5, J5, to enlarge these holes with an electrical drill to make them 1/8 of an inch. Okay, this is the actual reason I'm specifying the position of these holes, because these holes have to be enlarged. So for the two connectors USB-B, you're going to place, if they are on a breakout board exactly like the one in the bill of materials, you're going to enlarge the holes to 1/8 of an inch, or in the metric 3 millimeter diameter. So far so good. As for the other connector USB-A, it's coming exactly like this one here I hold in my hand. It's coming with 4 holes. And if you want to put screws on all the 4 holes, is the same gauge for the hole, but you need the holes placed exactly in these positions over there, P2, P6, X2, X6, okay? So follow the letters, follow the numbers, and then you're going to place these holes over there. Don't forget, you have to enlarge these holes to about 3 millimeters in the metric, or 1/8 of an inch in the American gauge. So far so good. This was the step number 1. Step number 2. On the same board, we still talk about the same board. Now having the USB for the PC1, the USB for the PC2 placed already, and the connector for the printer placed already here, I'm showing you now the position where you can place the toggle switch. Okay? So remember, the toggle switch itself has to be placed over there. But this one also has the pins a bit larger than the 0.8 millimeter holes in the printed board. So if I'm measuring this for you right now, this is approximately 1.6, 1.7 millimeters, okay? 1.6 millimeter is approximately 1/16 of an inch. So you have to enlarge the holes. You have to enlarge the holes on the printed board, on this one, exactly on that position here. For the position as I'm indicated there, T19, T21, V19, V21, X19, X21, exactly these ones, to 1/16 of an inch, respectively 1.6 millimeters, okay? Because this way you're able to plug the switch in order to solder the terminals. As you can see, it's not much of a wiring. It's not much of a wiring on the printed side. And here, a couple of wires around, okay? Just to have everything connected properly. This was how to connect the switch. If we go for the step number 3 now, step number 3 shows you exactly the position you are going to connect your relay. So your PCB relay, this time you don't need to enlarge the holes. You just need to identify properly the position for the holes for that relay. So it's going to fit exactly there on that position. Now, if you take a look, in order to make your life a bit easier, that group of contacts over here is not going to be used. This is why you have no notations on it. But this is the group number 1. This is why I have 1, 1, 1 is the group number 1. Common, normally closed, normally open. So I put it there the order of the contacts. You also have the document already in the Google Drive from the first video. And similarly, here on the top right is the group number 2, 2, 2, 2. Common, normally closed, normally open. And on its left, you have the group number 3 in use, common, normally closed, normally open, okay? And the coil is over here, is across the 2 pins. That's exactly the position you're going to put your relay. Across the coil, as you can see, is the little diode 1N4148. But again, you can also use one from the 4000 series, okay? And I placed the 2 LEDs right below the 2 USB-B connectors, because this way is easy to identify. Let's hit them one more time. So if I put the computer number 1, take a look, is this one over here on my right, the PC number 1, and I connect it. You can see right away the green LED going on, okay? And if I take now the computer number 2, so my second Lenovo computer over here, before I connect it, obviously, when I disconnect the first computer and connect the second one, there is nothing connected over the second one because the cable is in my hand. If I connect it right now, right away the LED goes red, so green and red, green and red. So you have to have the cables connected in order for the LEDs to pop up, okay? So very nicely, okay? It's a very slight improvement of the project. It doesn't change the functionality, okay? Okay? So that's it, guys. Remember, I'm gonna put all these documents online. You're going to have access to them.